I just want to go over with you guys excuse me, a Prelab discussion for experiment 4, which alkali metal carbonate, and we are only going to do part A. Don't worry about the second part, which is the titration. Also, we are going to do one trial because we have data for only one trial. So which alkali metal carbonate? So in this experiment, you will be given 3 different types of metal carbonates, and those are going to be either lithium carbonate, Li2CO3, it could be sodium carbonate, or it could be a potassium carbonate. If you are actually going to do this experiment in the lab, this will give it to you as unknowns. This could be unknown 1, unknown 2, or unknown 3, or it would be labeled as A, B, C. But we do have only one trial. Okay, one of the metal carbonate should be given to you. And how are we going to identify which one we have is we are going to use the law of mass conservation. So if you remember, the law of mass conservation is if you have A plus B giving you C plus D, the mass of reactants is going to be equal to the mass of the product. So these are the reactants, products. Reactants and products have the same mass. So that is the mass conservation, law of mass conservation. So for this experiment also, we're going to be using the same concept. Okay. So what we are going to do is we're going to react. So you're going to take one of these metal carbonates. I'm going to label the metal carbonate as symbol X. Okay. I will label this metals as X. So as a common term, I can say X2CO3. And then remember, X could be either lithium, sodium, or potassium. Okay. So let's see what we're going to do now with this X2 carbonate. What we're going to do is you take X2CO3, your unknown metal carbonate. And how much are you going to take? I think approximately about 2 grams. Okay, you're going to take approximately about 2 grams, and then you put it into a Erlenmeyer flask. Yeah, so you're going to take a flask, 125 milliliter Erlenmeyer flask, and then you're going to get the mass of the Erlenmeyer flask. Okay, that's going to be your first data, mass of the flask. It's given here as 93.1462. And then you take, in a weigh board, we have weighing boards. They are disposable ones. And you take that and you put about 2 grams, approximately 2 grams into the weigh board of your metal carbonate. Okay. You will have some powder, and then you're going to put these 2 grams into your Erlenmeyer flask, and then you will have some powder here. And then you're going to get the mass of the Erlenmeyer flask and the solid again together. And that's going to be the mass of the flask plus the unknown 95. You see, we started with 93, now it's about 95. Meaning about 2 grams, 95.2433 grams. That's the mass of the flask plus the unknown. So what we're going to do next is we're going to react this X2CO3 with hydrochloric acid, HCl. Okay, and then the molarity of the hydrochloric acid is 6 molar. Remember, we learned about molarity in chapter 4. And then this is a double displacement reaction. We'll see what are the products it's going to form with X2CO3 and hydrochloric acid. Remember, we learned double displacement reaction. X is going to react with chlorine, forming HCl. X is one of the elements from group 1, lithium, sodium, or potassium. They carry charge plus 1. So chloride is minus 1. So the formula for the metal chloride is HCl. Okay. And then plus carbon dioxide and water are the products that we are going to form. Okay. So I'm going to go ahead and erase this. Also going to go ahead and erase this part here. Okay. X2CO3. Now, how are we going to use the law of mass conservation? So, we know exactly the amount of metal carbonate that we're going to get. Approximately 2 gram. By the difference of the A and B, we can find out exactly how much metal carbonate we're going to have. And then to this flask, you're going to take a graduated cylinder, and then you're going to add 10 milliliters of hydrochloric acid. 6 molar hydrochloric acid, 10 milliliters to the graduated cylinder. And then you're going to get the mass of the hydrochloric acid with the graduated cylinder. And that's going to be your C, mass of the graduated cylinder plus HCl, 37.6565. Okay. And then what you're going to do is, you're going to take this hydrochloric acid and you're going to pour it to this flask. You will see all this in the virtual video posted on Blackboard. Please watch that, okay? And then what's going to happen, now you have metal carbonate and the hydrochloric acid. This reaction take place, so you're going to have your flask and you have a hydrochloric acid and then your metal carbonate, and then this reaction will take place making HCl, carbon dioxide and water. You will see some gas formation. That gas is carbon dioxide. So one of the products, carbon dioxide, will evolve from this reaction mixture. Okay, so you're going to leave it like that for 15 minutes. Take the flask and swirl it time to time to make sure that your reactants are mixed thoroughly, and then all the carbon dioxide that generate is going to evaporate from your reaction mixture. Okay, so after 15 minutes, what's going to be in your flask? Since carbon dioxide is gone, you will end up having HCl and water inside the mixture. Carbon dioxide, one of your products, has escaped from your reaction mixture. Let's see if we have balanced our reaction. Anytime we write a reaction, we want to make sure it's balanced. So X2CO3, 2HCl, and then you need to put 2 there. Looks like it's balanced now. Okay. Now, how are we going to use the law of mass conservation? So, one more thing I forgot to tell you. After you pour your hydrochloric acid into the flask, you're going to get the empty graduated cylinder and then get the mass of the empty graduated cylinder. By doing that, we make sure that we know how much exactly went inside the flask. If there are any droplets of hydrochloric acid left in here after you pour it to your reaction flask, then we know that amount has not been gone inside. So first you get the mass of the hydrochloric acid with the graduated cylinder, pour it to the reaction mixture, empty it, and then get the mass of the graduated cylinder. And then you're going to write that down as here, mass of the emptied graduated cylinder, 26.8530. So difference of the C and D will tell us exactly how much hydrochloric acid we have added to the reaction flask. So we know exactly the amount of hydrochloric acid we added. So that means we know the mass of our reactants, X2CO3 about 2 grams, to hydrochloric acid about 10 grams. So the mass of the reactants would be somewhere close to 12, a little bit over 12. Okay, 12 grams. And then this is our products. So the metal chloride, carbon dioxide and water, all of these masses, if you measure together, that should be equal to the mass of the reactants. Okay. Now what did we do? We're going to let the carbon dioxide escape from the reaction mixture. After 15 minutes, you take your flask that contain metal chloride and water, and then you're going to get the mass of the reaction mixture. That is mass of the flask containing reaction mixture, 105.1703. But in that reaction mixture we don't have carbon dioxide. Okay, then we also can find out the amount of metal chloride and water we have in the mixture when you subtract the mass of the empty Erlenmeyer flask. Okay, now let's say from the first these two together give us roughly about 12 grams, and all of these should also be roughly about 12 grams. Now if the carbon dioxide has escaped from the reaction mixture, when you get the mass of what is left in the flask, that will give you the mass of metal chloride and water only. So if you subtract the reaction mixture at the very end from your reactants, we can find out the grams of carbon dioxide we have in our products. Okay, so if you know the mass of the carbon dioxide, then we can find out the number of moles of carbon dioxide. Okay, and if you know the number of moles of carbon dioxide, the molar ratio is going to be 1 to 1. 1 mole of metal carbonate gives you 1 mole of carbon dioxide, and that will help you to find out the number of moles of metal carbonate. And then let me explain the rest in the next slide. Now these are the data that we got from our reaction. We have the mass of the flask plus the unknown. We have the mass of the graduated cylinder plus HCl. And then after you put the hydrochloric acid to the flask, empty graduated cylinder, excuse me, after 15 minutes, what is the mass of the reaction mixture? Now F going to be mass of the unknown. How do you find the mass of the unknown? Meaning the mass of the unknown metal carbonate. Which letters are we going to use? It is B minus A, right? So I have given you this information, how to do the calculations in your sheet. Mass of the unknown going to be B minus A. What about the mass of hydrochloric acid? That is going to be C minus D. Right? Mass of the graduated cylinder plus HCl given in C, and D is the mass of the emptied graduated cylinder. And then what about the mass of reactants? What are our reactants? Our reactants are metal carbonate and hydrochloric acid. So the mass of the reactants would be F plus G. Got it? When you add F value and G will give us the mass of the reactants. And then how do you find the mass of the products? Meaning what is left in your reaction mixture after carbon dioxide escaped. That is going to be E minus A. E here is the mass of the flask contained in the reaction mixture, and then the mass of the flask is A. So E minus A gives us the mass of the products. So J going to be the mass of carbon dioxide lost. How do you find the mass of the carbon dioxide lost? We know the mass of the reactants. We know the mass of the products. But the mass of the products is just for the metal chloride and water. So how do you find the mass of the carbon dioxide lost? That is going to be H minus I. H has reactants and I has the products, but we don't have carbon dioxide there because it escaped. So we can find out the mass of the carbon dioxide lost. And then K going to be moles of carbon dioxide lost. If you know the mass, you know how to convert mass to moles using the molar mass of carbon dioxide. Okay, that is going to be, you take J will be in grams, and then the molar mass of carbon dioxide is 44.01. So 1 mole you divide by 44.01 gram, that's the molar mass. That will give you moles of carbon dioxide lost. Now how about the moles of metal carbonate? Now to find out that, you refer to our balanced equation. So metal carbonate, 1 mole of metal carbonate gives you 1 mole of carbon dioxide. So the molar ratio is 1 to 1. If 1 mole of carbon dioxide is lost, meaning 1 mole of metal carbonate reacted. If you have that K amount of carbon dioxide lost, moles of metal carbonate also be the K amount that you get for the K. So it's basically the same value as K. That's the number of moles of metal carbonate. And then for the molar mass of metal carbonate, we can find out normally the molar mass is given as grams per mole. If you take 1 mole, what is the mass? So where we have the mass of metal carbonate, that is in mass of the metal carbonate, that is the mass of the unknown is in F. So you take F and you divide it by number of moles of metal carbonate, which is L. F over L will give us the molar mass of metal carbonate. Okay, and then once you figure out your metal carbonate molar mass, we normally calculate molar mass by, how do we normally calculate the molar mass? By adding the individual masses of the elements, correct? So we have X2CO3. X we don't know. We know the molar mass of carbon. Carbon is 12. There are 3 oxygens. Together we'll make it 60. So the more, okay, let me show you that calculation instead of talking through it. Let's go ahead and do all these calculations along with you. Okay, come on, give me eraser. Okay, let me go ahead and do these calculations with you. If you do B minus A, you will get the answer as, can you do the calculation for B minus A and tell me what you get? I thought I wrote it down somewhere, but it would be easy to do the calculation again. Okay, so let me do the calculation for you guys. B minus A, that is going to be 95.2433 minus 93.1462. 2.0971. 2.0971. And then the C minus D would be 37.6565 minus 26.8530. That would be 10.8035. You guys do these calculations yourself. Don't use my numbers. I might be wrong, okay? So do your calculations properly. So the mass of the reactants are going to be F plus G, which is 10.835 plus 2.0971 will give you a number as 12.9006. Okay, so that is the mass of the reactants. And then the mass of the products are going to be E minus A. E is 105.1703 minus 93.1462. So the mass of the products, that is for the metal chloride and water without carbon dioxide, that is 12.0241. So we're going to be using the law of mass conservation. Your products and the reactants have the same masses, but the mass of the products, we don't have carbon dioxide. So in order to find the mass of the carbon dioxide lost, we subtract the mass of the products from the mass of the reactant, H minus I. H going to be 12.9006. And that number is 0.8765. 0.8765 grams. Put the units when you are doing your calculations, okay? That's the mass of the carbon dioxide lost. So, 0.8765 grams carbon dioxide. We're going to convert it to number of moles using the molar mass of carbon dioxide. 1 mole carbon dioxide is 44.01 grams. That's the molar mass of carbon dioxide. So you divide this number by molar mass. That's going to give you 0.0199. 0.0199. And then the molar ratio, according to our balanced equation, the number of moles of carbon dioxide are the same as the number of moles of metal carbonate. So because of that, okay, so here 0.0199, which is same as the moles of metal carbonate, 0.0199. Okay, and then once you got the moles of metal carbonate, also 0.0199, we can find out the molar mass. So how do we get the molar mass? Molar mass is grams per moles. And this is for our metal carbonate. So the grams, the mass of the metal carbonate is mass of your unknown, which is 2.0971. 2.0971 grams, and you're going to divide it by the number of moles. So number of moles 0.0199. Okay, so 2.0971 over 0.0199, and that's 105. I may have not followed the proper significant figures, but you watch out for your significant figures. If it is a subtraction, you go by the number of decimal places. If it is a multiplication and division, you go by Fibers number of significant figures. So this one has 3 sig figs for 0.199. So I can keep the answer in 3 significant figures. So the molar mass is 105. Molar mass of metal carbonate is 105. Okay. Now how do you find the molar mass of X? Now let's say you want to find out the molar mass of lithium carbonate. What are you going to do? You're going to write the formula, right? And then you're going to get the mass of the lithium, mass of the carbon, mass of the oxygen, and you multiply it by the required number of atoms. Same way we found molar mass is 105 for X2CO3. So let me go ahead and erase this part. X2CO3. So the molar mass of X2CO3 is 105, meaning if you add the molar mass X times 2 plus carbon plus the 3 oxygens will add up to 105. Only thing we don't know is the X. X is the identity of the metal, could be lithium, potassium or sodium. And then the carbon molar mass we know 12. Oxygen is 16 times 348 equals 105. So 2x plus 60. 12 plus 48 equals 105. So then the 2x would be 105 minus 60. And that is going to be 45. So the x going to be 45 over 2, which is 23.5. Now, then once you identify the molar mass of X, you're going to find out from your periodic table to which element X is more closer to. Is it the lithium, sodium, or the potassium? And you're going to identify it as your unknown metal. And then the identity of the metal carbonate you have. So that is the experiment and the calculation that you should be doing, and to find out what is the identity of the metal carbonate. Okay. So you can write down the molar mass over here, molar mass of X, which I did the calculations for you. And then use your results from both trials. So we didn't do 2 trials, we only did 1 trial. Okay, so you don't have to do the average molar mass, but you can use your result to identify what is the identity of the unknown. Is it lithium, sodium, or potassium? It's given here. What is the identity? Basically, you don't have to answer this part. Identity, provide justification. For your justification, you can say that the molar mass of the unknown compound came to be closer to this atom. So because of that, that is the identity. Excuse me. And the actual molar mass of the possible alkyl metals are given, and you can calculate the percent error in your experimental value. And we have done percent error earlier also. So the percent error is going to be absolute error over actual amount times 100. How do you find out the absolute error? It is the actual minus the experimental. So your actual is going to be one of these, either lithium, sodium, or potassium number. And then the measured one is what you got, like the 23.5. And so when you calculate the absolute error, you have 2 bars like that. So this bar indicates whatever the value you get as the result, you only take positive value. You can have a, let's say you got a lithium, actual value is 6.9, but your number is 8. So 6.9 minus 8 will give you a negative value, but this bar indicate though you get a negative value, you only take the positive value. Absolute value means a positive value. Okay, so don't put any negative percentages. Okay, so that number you divide by the actual amount times 100 will give you the percent error. And then what possible sources of error are present in part A? Be specific, explain which measurements would likely have the greater error and why. Watch the video and see where the things can go wrong, and then come up with your own answer for that. Okay, be creative, think like a scientist, like a chemist, and then answer here. Okay. Excuse me. So that's our experiment, how to do the perform the experiment, and also how to perform the calculations. Okay. Excuse me. Now your pre-lab assignment is also pretty much similar to what we have done for the calculations part. In the first one, Jeff followed the procedure for lab exercise 4, collected the following. Date row A, mass of the flask and the unknown, mass of the graduated cylinder, and then the emptied graduated cylinder just like we did, and then the flask containing reaction mixture. Okay, use this data to answer all the questions in the assignment. You will perform exactly same types of calculations when you collect your data in the lab. What was the mass in grams of Jeff's unknown? What was the mass in grams of Jeff's unknown? So which letters are you going to use? That would be B minus A, right? So when you try to do this calculation, do B minus A. 99.86 minus 97.85. So you keep your answer in 2 decimal places. Okay, that's the answer for the first one. And then the next, what was the mass in grams of HCl? Okay, how do you find the HCl? Mass of the graduated cylinder plus HCl, mass of the emptied graduated cylinder. That's going to be C minus D. Okay, so that is going to be C minus D. So your C is going to be 37.470, 37.470 minus 26.941, 941. And remember to use the proper significant figures. Now here is a subtraction. You go by the least number of decimal places. So you write the correct decimal places. Okay. And then the next one. What was the mass in grams? What was the mass in grams of the reactants used in Jeff's experiment? Row H. Type the numerical value. So what are the reactants? They are going to be the sum of your values in question 1 and 2. Because the question 1 is the mass of the reactants. Question 1 is the mass of the reactants, the metal carbonate. Question 2 is the mass of hydrochloric acid. So basically, you're going to add question 1 and question 2 answers together. That's going to be the answer for question 3. Excuse me. Excuse me. What was the mass in grams of Jeff's products after the reaction was complete? Okay, so now the mass of the products are going to be, your row E is the mass of the flask containing reaction mixture, and then A is the mass of the flask. That's going to be E minus A. E minus A. E going to be 109.55. 109.55 minus A 97.85. 97.85. So make the answer up to 2 decimal places. And then question 5, what was the mass in grams of the carbon dioxide lost in Jeff's reaction? Now, how do we find the carbon dioxide lost? So we know the mass of the reactants. That's question 3, mass of the reactants. And then the mass of the products over here without the carbon dioxide. So question 3 answer minus the question 4 answer will give you the mass in grams of carbon dioxide. Okay, for question 5 you will do question 3 minus question 4 answers. That's the mass of carbon dioxide. And then how many moles of carbon dioxide were lost in the reaction? Remember, the molar mass is given. Now you take the answer from question 5. You take the answer from question 5. That will be in grams. And then you're going to convert it to moles using the molar mass of carbon dioxide. 1 mole carbon dioxide is the molar mass, which is 44.01 grams. You take the question 5 and you divide by 44.01. That will give you the number of moles of carbon dioxide. And then remember, our equation is X2CO3 plus hydrochloric acid giving you HCl plus carbon dioxide and water. And then the balance equation would be like this. So 1 mole of metal carbonate give you 1 mole of carbon dioxide. So if you have the number of moles of carbon dioxide in question 6, that would be the same answer for question 7. Same answer, same as question 6. You plug the same, you answer the same number. And then the question 8, what is the molar mass? Be sure to round off your answer to the correct number of significant figures. Question 8 would be molar mass. Remember, I explained you in the discussion for the lab. So the molar mass normally we give in grams per moles, M. So the grams would be the mass of your metal carbonate. And where do we have the mass of the metal carbonate? In question 1, what was the mass in graph? Jeff's unknown. So that is your question 1. You take the value for question 1. Take the value for question 1 and you divide it by the number of moles. So we have the number of moles in answer for question 7. So this is in grams and this is in moles. Okay, and then you're going to answer that. That's going to be the molar mass. Okay, and then the next one, what is the molar mass? What did we do here? What is the molar mass in grams? X2CO3. And then what is the molar mass of the unknown alkali metal atom? Now we're going to find out what is the identity of X. So remember X2CO3. How we calculate it? 2X plus 1 carbon plus 3 oxygen equal the answer you got for question 8. Answer for question 8. Question 8 that you got. And 1 carbon and 3 oxygen, this is molar mass is 60. So your X going to be then question 8 value minus 60 and you divide it by 2 will give you the molar mass of the unknown alkali metal. Okay. And then what is the identity? Based on that you refer what is the molar mass of the metal. You can find out whether it is lithium, sodium, potassium, rubidium or carbon. And then the last one, as always significant figures are important in lab where we deal to how many significant figures can Jeff calculate the molar mass of X if he is correctly using the rules for significant figures in all of his calculations. It would come to be as 2 significant figures. Okay, 2 significant figures. I hope this help you to do the calculations, even though I did not give you exact numbers from those subtractions and divisions. I believe you can do that instead of me giving you all the information. So since I want you to guide you how to do the problems correctly, but at the same time I want you to understand and you do some of this work, okay, because you want to learn how to do that. But if you have any questions, if you don't get the answers the way that I have explained here, send me an email so I can see where you went wrong. Okay, all right, I'm gonna stop here now and we'll meet in the next session. Bye bye.